welcome back to my C# OpenTK 2D Game Engine / Framework series, Part 4, Shader Abstraction. In this episode, we are going to focus on abstracting the shader from the previous video into its own class, as well as load shaders from a file. I am using a similar technique as the Cherno in a C++ OpenGL series. This is done a little bit differently and it's done in C#, but I will leave a link to the description to his channel below. So let's get started. First, let's recap very quickly what we did previously. We updated the vertices to not only supply the position, but also the color. We created a handle for a shader, we implemented a vertex shader and a fragment shader, and we linear interpolated that string to each vertex. I linked the program and compiled and linked the shader onto the graphics card. We updated our attribute pointer to let it know where the starting position is for the color, so that way when it got into the shader, it knew which out of this it needs to read. So it would be these last three here, and then in location 0 it reads the first 3 floats. So first thing we're going to want to do is we want to put these off into their own file. So in our main GameEngine.tk project here, let's add a new folder, and we will call it resources. And then within here we'll create another folder called shaders. And then in our GameEngine.tk.core, let's add a new folder / namespace to this, and we'll call it rendering. Maybe graphics? No, we'll just call it rendering. That's fine. And then in here we'll also create another folder for shaders. Just want to call out our actual shaders will be in the main project, and our class related to rendering and shaders will exist in here. So let's create a new class and we'll just call it shader. And let's put it in the rendering namespace. Make it public. Okay, so let's go ahead and remove the using statements that we would not be using. The only one we're going to need to make use of is the OpenTK graphics OpenGL. So using OpenTK.graphics.OpenGL4. And then we need to have the shader handle, but I think we'll just call it program ID, just to call out the difference here. So program ID, getter setter on that. Maybe we should only make this private set. I think it should be. We should only have a getter for that. I don't think we should have exposed being able to change that outside of here. And we'll have a. Let's see. Let's make a class that's going to hold the shader source. And the reason we'll want to do this is because when we'll call it shader program source. Because we may actually just generate shaders on the fly. This isn't going to be kind of a framework / engine after all. So maybe we won't always be reading it from a file, and we just want to provide it the source just by dynamically creating it on the fly. We'll keep this in the rendering namespace. We'll make this public. And then in this class, we will keep the string for the vertex and fragment shader. So we'll do public string vertex shader source public string fragment shader source. And let's go ahead and generate a constructor with these two. And I think that's it. This is mostly just going to be kind of a model for our shader source. So let's create a constructor here in our shader class. We'll go with generate a constructor. We will not be passing in program ID, and we'll accept a shader program source, And let's keep a private instance of this as well. I think we should have to supply it through the constructor. We'll do that for now. Okay, and we'll just say shader program source equals shader program source. Now we're going to want a method that's going to compile the shader. But first, let's update this to start pulling it from a file. Because we're going to, in order to compile a shader, you're going to need to supply a shader program source. So what we can do is we can just make a static instance of this that's just going to pull out the shader source and give us an instance of program shader source, or shader program source. But you can really do this kind of however you want. I think we'll just go with this for now. So public static shader program source parse shader and do string file path. And for now we will just return the shader program. Okay. That's right. I'll just hit string. Let's go with that for now. So now let's create a file, and the quickest way that I've found to do this is go up into your shaders here, right click, and then do open folder in File Explorer. And then in here we will open up Notepad. Go ahead and copy this location wherever it is on your machine. Go in here, hit save, paste this in, and then change your save type to all files, and we will call this Default.glsl. The string extension technically doesn't matter, but the only thing that really would matter is if we named it .cs, because then obviously the compiler is going to pick it up as a C# file, and GLSL is definitely not C#. One more step here. Make sure you do this. This is important. Go into your shader and then go into properties. Sometimes it might not show here. If it doesn't, hold down Alt and hit Enter, and that will open up this window. And set the copy to output directory to copy always. And go ahead and hit Save All. And then now we need to bring over the shader that we hard-coded in our project to be in here. So let's go into our original project here and let's copy the code, just the string, and then let's paste that into default here. We will want to clear out some of the space here. And we'll add tabs here. And we'll do the same for the vertex shader. And you might be wondering why we're putting it all in the same file, because wouldn't vertex shader and fragment shader need to be two different files? No, because we're going to write our parser to look for specific text and then only copy down the source or get the source if it meets a certain criteria. So what we'll do here is we will first, let's create an enum, and we can just create this enum in our shaders folder here, and let's call it eShader type. And we're going to append it with E here because we don't want it to be mistaken for OpenGL's shader type. So that's why we're going to call it eShader type. It might get kind of confusing, but I think we're the ones who are handling this. Maybe what we'll do is we'll just keep this in a full-on rendering.shaders namespace. So this way, chances are the only thing that's going to use it will have to be using this namespace, and there's no chance anybody that you'll accidentally use it, because we won't make shaders and namespace something that you would want to use. I don't know if there's a way to restrict that in C#, but maybe not. So we want this to be public enum eShader type. And for this enum, we'll want to keep the numbers on here. So I'll explain what these are in a moment. So we'll have none, which is equal to -1. We'll have vertex, which is equal to 0, and fragment, which is equal to 1. make sure you have the number set on these, and let's remove the unnecessary using statements. And I'll explain what these are here in a moment. So in our default.glsl program, what we'll do is we'll add some syntax that is not actually OpenGL syntax or GLSL. We'll call it hashtag shader. Oops, we want this to be lowercase. Shader vertex. And then above the version 3.3.0 core for the fragment, we're going to say hash shader fragment. And this is so that our parser can look for this text. If it finds this, says, okay, go to the next line, and then read. It'll then check when it finds hash shader and fragment on the same line, and then just copy everything down from here. And we're going to use the enum so that way we can call out which shader that it's using. None would mean that we haven't currently found anything with that, but since this will be our first line, once we start reading that file, that should be the first thing it finds. So back into our shader file, let's do a string array called shader source. And we'll set that to new string, and it'll be the size of 2. So it'll allocate 2 strings for us. We're going to do eShader type, and we got to bring in our shader's namespace. Shader type equals eShaderType.none, because we're not currently writing to one. And then now what we'll do is get all the lines, so var all lines equals file.read all lines, and then the file path that we're passing in. And the reason we're not using async, which you might use if you were working with some kind of traditional .NET application, is when it comes to multiple threads, even though async technically I think uses the background worker threads, but in any event, you cannot use async or any type of threading when you're working with this. I'm sure you can, but it requires quite a bit of extra work. We're going to keep this pretty synchronous. There might be some things that we make asynchronous when we actually get into more of like game engine functionality, but anything related to rendering, absolutely not. I think I made a typo here. Yes, I did. Type. There we go. So now we're going to loop through all of the lines. So we'll do for int I equals 0. I is less than all lines, dot length. I plus plus. And then we'll check for what the current line is. So string current equals all lines, and then I. Then we'll check if current dot to lower, because we want to make sure we're not going to mess this up by doing casing by any mistake, dot contains hashtag shader. Then we know we've hit one of these lines here that has shader in it. So the next thing we're going to check is, does it contain vertex shader, or does it contain fragment shader? So we will check inside here if current dot to lower dot contains vertex, then we're going to want to set the current shader type to eShaderType.vertex. And that's all we need to do there. Else, if current dot to lower dot contains fragment shader type equals eShaderType.fragment. And then I think we probably want an else statement in here. Might want to throw an error, maybe. For now, we might just log this out as an error. So console.writeLine error. No shader type has been supplied. Okay. Otherwise, if we're reading through this file and it hasn't found the word shader or hash shader on here, that means we can just go ahead and write to our shader array here with the eShader type. That's why the 0 and 1 come into play. So we will do else shader source, and then we want to convert this to an int, and then shader type, which would be whichever one we're currently on. Do plus equals current plus environment dot new line. Oop, not shader source. Sorry, shader type. Shader type. And then I think all we need to do is, instead of just returning an empty one, we just do we'll cast this to an int. A little bit differently. We want to do shader source. Yes, int e vertex e shader type dot vertex, and then we'll do the same except for fragment over here. And if we did that right, this should return us the shader source that we need. Okay, so let's test that real quick. Let's see if that worked. We'll just, right inside of our load content method, let's just make sure we got shader source. So we want to do shader program source. We want to bring in OpenTK.core.rendering. S source equals shader dot parse shader, and then the path will be resources slash shader slash default.glsl. So we'll do resources slash shaders slash default.glsl. And then let's see if that worked. We'll go ahead and put our breakpoint here. And it looks like it did. Let's confirm these values look correct. So our fragment shader source is version 3.3.0 core, version 3.3.0 core. Position, that's right, we are not getting the right values back, are we? Something doesn't look right. One moment, I will take a look and see what we can find on this. So there was actually no issue. It was correct, I just looked at it wrong. So if we go in here, I was looking at fragment, I thought this was vertex, and I was wondering why we weren't setting the GL position, but no. So the vertex shader, yes, it matches what we have here. So if we compare it, version 3.3.0 core, location 0, aPosition, aColor, vertexColor, we're setting all that correctly. Close this out, let's scroll down, make sure our fragment shader looks good. And we'll look at our fragment shader source. And there we go, we have our vec4, 3.3.0 core, vertexColor, color equals vertexColor. Cool. So now we have exactly what we had here when we were hard coding it, but now we're reading it from file properly. So next we will actually compile the shader and do some of this, and we will mostly be able to just copy some of this code over. I'm trying to see if there's any reason we couldn't just copy it. Let's do that. Okay, so let's start by copying all of this and pasting it into our shader method. Well, we have to create the method yet, so we'll call it public bool compile shader, and then let's do a check to make sure that that the shader program source isn't null. So if underscore shader program source equals null, we will write to the console explaining why. Shader program source is null, and then we'll return false because that's no good. We might want to have it throw an exception here. We can come back to that and do that later if we want. So what I think we would want to do here is probably use another string to keep track of these. Maybe not. Maybe we'll come back and refactor this a little bit differently in the future. So we have a vertex shader, and we don't need these integers as top-level variables. So I think we can simply... Oh, what's that? Does not exist in the current context, because I think we have it here. Vertex shader. Oh, okay. So our vertex shader source here. Yep, got it. So it would be shader program source dot vertex shader source, and then we'll do shader program source dot fragment shader source, and then instead of shader handle, we called it program ID. We're just gonna go with that, so we'll call it program ID. Just update these handles here to program ID, and it's calling delete, so we're doing all of the cleanup work. Can't we do something like private sets or something like that? There we go. Okay. Yep. So we have public getter, private setter. Okay. And I think, yeah, now we just need to call a method that's going to use it. Actually, first, let's make sure we're gracefully handling this. So we're going to return false. And we want to return false here too if there was any errors during the compilation process. And then we want a method that's going to actually use this shader. So we'll do public void use, and then gl.use program, and use program ID. And I think that might be all we need to do for this method. You know, maybe what we should do is let's make an optional parameter here. So when we call, maybe we just want to go ahead and just provide the source and compile it right then and there. And if we want to do that during the construction process, let's make that be an option. So we'll do bool compile. By false, this will not be the default behavior. And if it is something that you choose to do, we want to make sure we're not calling compile twice. So let's also add a method here for if it was compiled, and we'll have it be a get and private set. Maybe this doesn't need to be public. Okay, well then we'll do this. So if compile is true, we will compile the shader, and then we will also want to make sure we're setting if it was. So in compile shader, we'll set this to true. And then in our compile method, we'll also want to check if we already compiled it or not. So we'll also add another check. So if it's been compiled, we'll want to console dot write line shader is already compiled, and then we'll return false as well here. Okay, so this way we added a check to make sure it's not already compiled, and we have an optional command to just compile it when we instantiate it. Okay, so I think that's good for this class. So let's go back into our test game, and we can delete all of this code. Let's remove it. And we can remove the use program. We'll eventually call shader, and let's create a private instance of the shader. We can get rid of the handle too. So private shader, and then in our load content method, we'll load it. So we'll do shader equals new, and we'll provide it the shader program source. So we can just do shader dot parse shader and resources slash shaders slash Default.glsl. And that's all we need to do there. And then we'll also call shader.use to replace that. And if we did everything correctly, this should just work. Let's find out. Okay, so we made a mistake. Let's make sure we're doing everything correctly here. Or wait, is this shader set up to... Nope, it should be interpolating. Let me take a look here, one moment. Okay, that makes sense. We never actually compiled the shader. We created the shader, but we never called compile. So we could do that by just simply passing in true here, and then that should compile it. Let's run it and make sure that does work. Yep, so that works. Now, what we can do if we don't want to, say we just wanted to load it, we don't want to compile it yet, we can just call shader.compile, compile shader, and then make sure this still works. Yep, that looks good. And let's make sure we can't make a mistake by compiling it twice. So it'll still work, but it should say shader's been already compiled, but everything's works, so we're handling it gracefully. And one thing we could also probably use here is maybe we check if it's been compiled or not. So let's do that. So if it's been compiled, we'll go ahead and call useProgram, else console.writeLine shader has not been compiled. And let's see if that works. Okay, that all works. Let's do it without compiling the shader to validate that also works. Remove this. And we get a black, but it's screaming at us that it hasn't been compiled yet. So let's go ahead and just change this back. All right, so I think we'll wrap the episode up here. In our next video, we are going to start working on loading in textures. We will take a look at and see what we can do to start drawing more than just a triangle. Maybe we can create a quad with 2 triangles, or we'll just draw a raw quad. And then we'll start going a little bit more in depth with the shaders so we can start making use of a camera class. And I think once we get that, we'll start be able to make this into a reusable library that we can use in our own game. If you like what you saw, please like and subscribe, and we'll catch you in the next episode. Thank you.